With a partnership extending over 25 years, Star Water founders and technology inventors Eric Love and Christopher Rochford have given society many groundbreaking environmental technologies and practices in the stormwater, recycling, waste, agriculture, landscape and construction markets, including innovations that are now commonplace in the Australian community, such as wheelie bin systems and composting recyclable organic waste. Welcome, Star Water.
Thank you, Jamie. Rarely does a technology emerge that solves threatening environmental crises such as climate change, water pollution and waste recycling, while simultaneously lowering costs and increasing economic, social and environmental sustainability. Star Water computer-designed advanced stormwater biofiltration systems do. Improving on sandy loam filters, Star systems hold the future, effectively removing pollutants like heavy metals, nutrients, hydrocarbons and bacteria from stormwater runoff, protecting human health and safety. Biofilter plants collapse in sandy loam but thrive in Star systems. The secret is custom-designed reactive filter meter containing high recycled content that physically, chemically and biologically removes pollutants. Significantly advanced biofilter functionality reduces customers' CapEx and OpEx costs. More efficient hydrology enables smaller biofilter footprints, producing higher lot yield and lowering the cost of housing development. High performance, low cost, long-lasting, cost-effective Star stormwater filter meter is welcomed by contractors building wooded detention basins and rain gardens. Star systems produce recycled stormwater for reuse, alleviating imposing water restrictions. Validated technology positions Star to access the $100 trillion climate-responsive infrastructure investment required to meet the 2030 Global Paris Agreement targets. Connecting to the current projects like Western Sydney Development, gaining research connections and securing capital, our expert team will continue its purpose to give communities clean, safe waterways and harvested reuse water, creating a more livable and sustainable environment for everybody.
Thank you, Eric. You mentioned the reactive filter being made of recycled product. What are we recycling?
We initially started recycling recycled organic materials because we did some work back in 2000, in the mid-2000s, to see whether recycled organics could play a role in treating water. So the first blends had the recycled organics, but we've recently installed a 100% recycling biofiltration basin in Newcastle. So now we're recycling glass, wood, and also recycled organics from the curbside.
Right, thank you.
I'm just really interested in the go-to-market strategy. So who is your customer? I know in this instance you work with consulting engineers and contractors and councils and construction firms. Who do you primarily sell to? I'm interested in.
I'd like to invite Chris Rochford to the podium to answer that question.
Thanks, Eric. Yeah, it's actually all of the above. So we have different influencing methodologies and that for each target audience that we target for selling products and that too, whether it's the councils or construction companies. But the main influencers are the consulting engineers and the regulators and that, and they're the ones that we influence initially and be able to provide them with our long-term data on how these products work more superior than the conventional. And then we target the councils and the construction companies on a one-on-one basis.
So have you been able to get your products written into technical specifications and scoping documents?
Yes, we're just at that stage where we've been able to do that. And right. Transport New South Wales, for instance, has specified our products in through an influencer, which is a landscape architect. Yeah. So it's a two-way approach to that. And so we've got it written into there. We've got standards that we've established, industry standards, voluntary ones at this stage. And they are helping to advise and that everybody involved in putting these sorts of systems in to make sure that they're more advanced than what we've put in the past.
So is that for these guys, Matt, the sort of thing they need to do is be getting that into the regulations and standards?
Well, whether you can get yourself written into regulations is going to probably be a challenge, but educating the people that put the ideas forward on your behalf is what you're doing. So that sounds like the right strategy there. I'd be interested to see how you're going with local government, because you'd be putting it into public domain and it'll be the councils that then have to look after what you leave behind.
The process is really in a development. For example, the developer develops and gets their contractors to install on the specifications from the council. And then then it's handed over to council in the end, so it becomes a council asset. So that's why council has such a predominant role in that. And look, who writes the purchase order? It is either the contractor, but our recent orders are mainly from councils or council contractors. That's the main target.
I know there is a lot of willingness in the corporate world to move towards more sustainable solutions, but at the end of the day, there has to be a value proposition. I'm interested to hear you talk a little bit more about the CapEx and OpEx savings on the one side, but also the quality control on the other side, because obviously you've got to be as clean or fit for purpose as something that is new. So how do you ensure that that is the case, but at the same time achieve cost savings?
We've had an extensive, program of testing over the last 10 years, assessing the quality of different components. And we select our components specifically. We're local. So when you're talking about cost savings come from the lower cost inputs, but those inputs are also scientifically tested to make sure their efficacy is high, and also that they don't cause any environmental harm. So the proposition for cost savings in terms of OpEx and CapEx, the operational costs, because we have higher efficiency than the current technology, which is sandy loam filters. So because we got higher efficiency, we're able to shrink the footprint. Now, when you shrink the footprint, obviously you got less product going into there. You create more space, so you get higher lot yield, which lowers the cost of housing on that particular development. So high specifications for those materials. Scientific testing. We have an accreditation system for those materials that tests them for things like environmental stability and efficacy. So those tests are carried out pretty well on every occasion that we try a new material.
Perfect. So you win-win. You're better for the environment and better for the profit line.
Also, in terms of the overall cost on a development, the sandy loam filters aren't lasting very long. They're lasting about 5 years. Our efficacy goes out to about 20 years. So you're not replacing those filters as frequently as you are, and they're not working very well anyway. So the plants are the main problem. You can't grow plants in sandy loam soil. That's a fact. That's why the landscape architects that Chris mentioned are on side, because we can grow really healthy plants. Healthy plants grow healthy roots. Roots take up more contaminants. So that's where we get our efficiencies. We also have higher conductivity than a sandy loam soil. So the higher conductivity enables again to shrink the footprint, achieve the same pollution removal efficiency at a much smaller footprint, and that's got all sorts of benefits in transport and all sorts of logistical savings as well. So in the life cycle of the product, we're much cheaper.
Love it.
Great.
Excellent.
Thank you.
Terrific.
Thanks, guys.
Thank you. Thanks,
Thank
Eric.
you.
Thanks, Chris. And the idea that it lasts longer and uses a lower footprint, that's genius.
Yeah.
I'm still interested in what they're putting in. I think it'll be interesting.
Yeah. Whether it is a truly sustainable material